IoT Unplugged, where we talk to industry leaders, innovators, and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more.
In this episode, I'm joined by Stephen Keetley, Head of Design at Pressac. He shares with me his thoughts into the wireless sensor market, talking more specifically about energy harvesting devices and key deployment considerations. Hi Stephen, thank you so much for joining me today.
Hi, I'm happy to be here today. Thank you for giving us the opportunity to chat to you.
So for those listening, could you just provide a quick introduction to who you are and what you do?
Yeah, absolutely. I'm Stephen Keetley, the engineering manager here at Pressac Communications, and my background is largely in electronics and embedded systems. I've spent around the last 10 or so years working in specifically the IoT industry, ranging anything from construction in hazardous environments in tunnels through to leisure applications in remote locations where telecoms isn't easy. Cellular coverage isn't great near the edges. And also now smart buildings, smart factories, data centers. So yeah, been around a while.
Great stuff. And could you introduce Pressac as well?
Sure. Pressac has been around for 60 years. It's got quite a long legacy and a wealth of experience. Initially being more of an automotive supplier and then migrating into that large-scale telecommunications equipment provider. And then more recently, IoT device manufacturer over the course of the last 10 to 15 years. It's fair to say we've probably been on quite a long journey in communications in general, right from early ADSL, wired communications right through to now the wireless revolution we go through. Specifically in IoT, we specialize in designing and manufacturing IoT devices. And our focus is really getting the hardware right. We know our space. We kind of solely work on the sensor side of it, and then provide the software to agnostically connect to various cloud platforms. And then customers can take that data however they wish to see the information that they need, and that a large part of our strengths, kind of what we're going to talk about today, and I'm excited to talk to you about today, is creating energy efficient wireless devices and specifically energy harvesting devices. So, yeah.
Good stuff. And we will be delving into wireless sensors, and there's obviously a lot that goes with these devices that companies need to know. So I'm hopeful that our conversation will provide a steer. But before we jump straight into that, why don't we talk a little bit about the state of the sensor market? What are you seeing? What are the big drivers of growth?
Yeah, I've got to admit the sensor market is kind of incredibly dynamic right now. The rise of smart buildings, sustainability initiatives, as well as the ability to kind of remotely monitor devices, really the demand has accelerated. We're seeing a lot of the drivers in operational efficiency, getting back to the workplace, understanding how people are utilizing that workplace, the environmental, social and governance reporting that people need to do, and then the facility to be able to retrofit. It's great kind of constructing smart buildings from the off, making them smart and in an ideal solution. But there is a sustainability and reusable point of retrofitting. Don't want to knock down a load of buildings and then recreate a load more buildings. And that's really where we're seeing that kind of growth. With that, there is that low maintenance battery free solutions where we're seeing a lot of the kind of interest for Pressac. Particularly, the growth is split into three different areas for three different kind of reasons, or predominantly two really big reasons. We've got occupancy, where people are looking at the occupancy of a building, and you can have that through just normal kind of door, people walking through a door, or people being on a site. But people really want to delve into that detail now and go, how many people are in a floor? How many people are in a room? From a hospital perspective, it might be how many people are in a ward, or how many beds are occupied. Really, people are trying to understand the capacity in the space and how they use it. From an energy point of view, people are always aware or firmly aware of the increasing rises of energy costs. So with the massive rollout of smart meters on sites and the reporting people need to do for that, people now want to know where is their energy going, and getting that granular detail on electrical subcircuits or machines and building that pictures to really, really key. And so the first two are really geared in terms of monetary incentives to really do well. Final side of it is really environmental side, where that's driven by forward-thinking companies and compliance, where businesses want to ensure they're looking after their people, their associated health risks, and toxic gases, whether it's formaldehyde or any of the others. And there's really quite an interesting study on that, which was done by a school in really understanding the concentration levels associated with students and the link of monitoring CO2 levels. And when you open a window or don't open a window, there was a whole COVID kind of scenario as well, but it became really, really interesting in knowing student performance based on monitoring CO2 levels. So kind of compliance side of it as well, seeing growth.
I do remember reading about that study, and I think they found the higher the level of CO2, the more students struggle to concentrate. And I definitely this parallel being drawn between monitoring and environment, and helping with initiatives is certainly becoming stronger. So you touched upon energy harvesting. It would be great to get a better understanding of what that is, what energy harvesting devices are, and how they work, and where they suit.
So energy harvesting devices kind of says what it is on a tin. It generates its own power, capturing that ambient energy, whether that's kinetic energy from motion, such as light press switches, light, solar, thermal differences. Here at Pressac, we primarily dominate having a looking at the solar and electromagnetic induction on a wide range of sensors, because that kind of best suits our kind of use cases. And these are really ideal in running, replacing kind of batteries where running cables aren't ideal, or interrupting power, such as like commercial buildings, where the back of the machine is constantly on. It has to be maintained, has to be powered. We cannot cut out that sub-circuit. So again, kind of that retrofittable kind of side of it. So it's that kind of fit and forget. You don't have to go in, replace a battery into that kind of hazardous environment or the dangerous environment, therefore making deployment easier, longer term maintenance, and kind of essentially being virtually zero. With the energy generated being quite low, unless you've got a large solar panel on someone's roof generating kilowatts, people like small devices. They want discrete devices sticking on their walls, etc., under desk. So the technology is really quite limited in terms of what you can use. As an example, really, you can do motion sensing and detection or presence detection using a PIR, which is a lot lower power applications in terms of using maybe something which is millimeter wave radar. And also the case of, from an energy point of view, where you've got a CT clamp, which is non-mechanical, and the energy can be captured, attached to an oven or a chamber while it's on. And it's just purely doing the ADC samples when the energy is on, and then quickly kind of shutting back down and then booting back up again periodically, however it might be, to save that kind of really valuable energy. Another really key consideration is the shipping and the limitations on shipping, in terms of how they best suit. So lithium, typically batteries, whether that's lithium thiochloride or lithium ion, classed as dangerous goods, shipping around the world. Energy harvesting don't have batteries, so there are perks associated with that as well, where it sees fit in the particular application. So lots to kind of go at.
Sure, and I'm sure for those listening, lots of things to take into consideration. One thing that's interesting perhaps about energy harvesting devices is when we look at standards. As I understand it, there's no one standard for every energy harvesting device. So it would be good to understand, for the energy harvesting devices that you guys manufacture, what protocol they're based on and why.
Yes, we predominantly utilize an Ocean wireless protocol in our devices. We was an early adopter of the Ocean, and also a part of the Ocean Alliance. I myself a part of the technical working group as well to help further develop that and the new challenges it kind of faces. It is far lesser well known than Wi-Fi, your Zigbee, your LoRaWAN. However, it is a wireless standard, it is an IEC standard. So, and it's specifically been designed with ultra low power devices in mind with the outset from the off when it was done by the founders, knowing that they want to really utilize energy harvesting. And so kind of really fit a lot of the ethos in where we wanted to go for our sensors. For us, it showed us being really reliable, secure, and had that ecosystem of interoperable devices because it is standardized. Where the InOcean protocol really kind of comes into its own for Pressac based products is that it only needs like 100 nanowatts and also an extremely short kind of latency time on airtime to transmit a bit of data. So it's really kind of very well positioned for our devices. Really kind of getting up, booting, joining the network, rather than doing all those kind of things, which you might find in other kind of networks with that level of overhead. It really kind of needs to do what it needs to do and gets away and does it. So it kind of positions itself quite well for us, and that's why we always kind of backed it from an early position.
I don't think you can understate the importance of something being low power when you're talking about a teeny tiny device that needs to monitor everyone in a building, for instance. So following on from that, do you think there's a need for these devices to be standardized? Do you see that being really important?
Absolutely. And that's, again, some of the reasoning behind us choosing InOcean. And create, instead of kind of creating, we could have gone off on a different spiel and created a proprietary network, which was highly optimized for Pressac and only Pressac to use it. But it really helps us from that interoperability point of view, but also kind of builds the trust as well, because you almost have miniature partners rather than competitors. You have miniature partners littered around. And as more manufacturers enter that space, it really helps build that trust in the protocol, the InOcean protocol, with also that level of clearer standards with the InOcean side of it, or standards in general. It really helps system integrators, with the people that we mainly work with, mix and match those devices with a level of confidence, because there's a level you need to achieve, knowing that they will work together accordingly and kind of have that broader adoption. As an example of how InOcean really, or the InOcean Alliance really help out in that situation, when a new data payload kind of is created, or a new device is created, and people can't just create their own kind of one, they have to submit it to a board. It has to be approved. They'll heavily scrutinize it accordingly and really make sure it's fit for purpose for what their objective and ethos was around the InOcean Alliance, of that short minimum data send, ultra low power design. And it really kind of makes you think about it at that really kind of low level in how you design it as well. So really useful to be standardized, particularly in that energy harvesting kind of sort of constrained way.
I think one good point you made was around trust. I've heard people mention that before when it comes to standards, trusting that the device will work, trusting that, standards are continuously updated. They're not just one and done. So with something like energy harvesting, which is an emerging technology, the hope is that will evolve and that will improve with time. With everything we've spoken about, then what are the big opportunities for energy harvesting devices?
For me, one real big one is the retrofitting. There's millions of buildings out there, and there's always that need now to have that key occupancy monitoring, that smarter energy, but then the rewiring associated with it is quite costly. And so having energy harvesting centers where, you have that drop-in upgradability with limited disruption is really kind of key. The other side of it is also the ESG, as I previously mentioned, and the sustainability reporting coming in there. There's starting to be emerging standards of people going, right, this is really important data and we need to be doing something about it. And people want to be doing something about it as well. And it's following them kind of forefront innovative companies and legislative standards to really kind of be on that forefront of technology. And then getting them sensors in place to continuously monitor that data cost effectively. At Pressac, we like to have the ethos where our sensors are quite discreet. You fit them, you hopefully don't forget about the brand and Pressac in general, but you kind of forget them. They're kind of part of the building, burrowing away, kind of capturing that data, reporting that data over a super long time, and have super low maintenance, just telling you how your building's performing. You need a sensor which kind of works for you and you don't work for it. And what I kind of really mean for that is, what I would pose to people probably listening is, as you're building your kind of strategy for innovation and smart monitoring, think about your growth. So if I have new buildings, if I have extensions to it, how am I going to maintain that? Whatever growth plans you've got, factor in the fact that you may have to have an increased workload for your maintenance team, or an increased workload or creation of maintenance team. How are you going to manage it? Or do you need something which is going to be more discreet, more fit and forget, in there just living and giving you that data that you need? Often people might not even consider that. So it'll be really, really, really good to get to hear people's thoughts on it.
So that I think that leads me on nicely to my next question, which is around limitations. What are you seeing from a technical perspective? Are there any technical limitations that are perhaps prohibiting the growth of the market?
So absolutely. For energy harvesting, how I typically look at it is physics. There's only so much power out there, and what's available, either from solar or electromagnetic or vibration or whatever, for you to perform whatever actions you need to perform. You can't invent it. As much as it is free energy, it is harvesting from something. And so really what is happening about that is, what's improving it in terms of growth is faster, better microcontrollers, different operating modes, whether it be right into the nanoamps, because things are getting smaller, faster, better, which all helps. I guess the caveat really for that is, what's really understandably happening over the course of the last 15 or so years is this IoT boom. Everyone kind of said, you've got billions of devices out there, and people want the data. They want that insight into their business. But now they're starting to say, I want secure data. And what level of authenticity, validation, encryption you need to achieve that, because people are very precious over their own data. What that hears to me is, while I want to boot up and do what I need to do very quickly with the limited energy I have, I think of it going, well, that's extra overhead I need to do. That doesn't necessarily mean that we can't achieve it, but how are we going to do it? And how is that factored into your power budget with energy harvesting, which is quite little? And so the hot topic really for us over the course of the next 2 years is, the recent cybersecurity standards and the challenges it's going to pose on IoT devices from a network perspective, not necessarily from an internet perspective, but from a network perspective. Whether that might be firmware over the updates when you're not quite sure when you're going to get power, because you don't know when the oven's going to be on to harvest it. Overall, compliance is pushing for, and rightly so, is pushing for stricter, more secure communications. It's just managing it and really adapting accordingly. Really, really interesting space to be in over the next few years for sure. And engineers, as what my kind of came from, kind of like to solve a problem. So roll up my sleeve and off we go.
Which is a good thing, because when we talk about devices like these, when we talk about deployments, there are always problems to be solved. So it's going to be interesting to see how compliance will impact on that. For those that are listening and might just simply be thinking, where do I start when it comes to deployments? What are your key recommendations?
So really, for me, it's always a bit of a give and take. And energy harvest isn't always for people for their own solution. So really get to understand the problem that you want to solve and what rules you want to put in place whilst doing it. So yes, I want to solve a problem, but what are my give and takes? So again, kind of coming back to, do I want a maintenance team going around every single year replacing batteries because I have a global kind of level of deployment? So what are the problems you want to solve, but equally as much, what is your give and take? Energy harvesting might be suitable, it might not be suitable, but really it's all around what you want to achieve. And so understanding those trade-offs is really, really important and helps you selecting the right solution. And it could just be simply asking the questions of, what information do I need? Why is it important? to make sure you're sending the minimum data set or the right data set that you need. What level of accuracy I need, or what granularity of data I need at the right level to provide me the right level of insight. And then how will I manage that technology moving forward? What is my strategy for managing that technology? What do the next years of growth and roadmap for an Ocean look like, or Zigbee or Z-Wave or whatever you might want to choose? They're the really kind of key questions I like to ask people, and people to be aware of and understanding it, because energy harvesting can be right for people. It might also not be right for people. And so really kind of think about it from that higher level, really.
I think it's always the challenge with the new technology, just understanding where does it fit in for me, and sometimes if it fits in. Given we've spoken about power, form factor, data security, are there any approaches you at Pressac are taking to take into consideration these requirements?
Yes, it's quite energy harvesting has been around for a while, and like I said previously in the podcast, that it's physics, and you have to harness it, and the ways of doing it and having faster, smarter chips are always there. The most interesting conversation I'm having at the minute is really to edge AI or not to edge AI. And so again, I kind of think about it and go, from our standpoint, getting that data into the cloud and performing what you need at that powerful level where you have power available to you, and pushing that computational power usage on the server end or the data center alike is really kind of useful. However, where the complexity comes in. Yeah, no, there is always however. When you get complex data sets, so it's not just a case of I've got an open or a closed circuit. I've got an open door, a closed door. I'm reporting current. You may be sensing time of flight or a continuous stream of point cloud. You kind of want to do something at the edge, because that's a lot of data to transmit over a period of time. So you've only got so much airspace and much time to air in accordance with EU Red Directive, Radio Equipment Directive. And also that consumes a lot of energy. So you want to kind of bring that down. And so doing some level of algorithm, some level of computation kind of helps with that, bringing that kind of airtime down. What really then becomes interesting is really giving a room an understanding of what it's doing. So the combination of sensors, such as sensor fusing or using sensor fusion to go, okay, I've got an occupancy monitor and CO2, which also gives me extra attributes to knowing who is in the room, how many people are in the room. People are really starting to patch together that data, and whether they can talk to each other locally is really becoming what might be next. Could be possible with faster, more capable processors, which can boot up and do what they need to do. But because much that also still consumes energy. So my point really to designers out there, when designing these kind of things, or people listening, is really to understand what is their power source and how people are using it. So, do you have a lot of power? Is it continuously on for a power? What is the level of current, for instance? Do you have 200 amps available to you harnessing current, which is going to give you quite a bit of return to harness? Or are you looking at the 1 amp where you don't really have a lot, so you can't report as much? And then getting it right down into that low power state. And again, kind of coming back to the key considerations of choosing the right charge controllers, choosing the right microcontrollers, where the product data sheet may claim it can go into ultra low power state and everything. Really think about your application, and what you really need to be asking is, what's left running? How am I going to wake up from it? What triggers am I going to use to wake up from it? And perhaps I might need an RTC or real-time clock running, which then bumps it into the hundreds of microamps rather than the nanoamps, and you want to be in that nanoamp scenario. And then from the front end side of it, of how I power it, supercapacitor are generally reasonably commonplace in terms of energy harvesting to almost create that battery effect. How big or how small you want to go with creating that understanding that power budget. So where you go too big, you've got a longer lifetime to do the computational stuff that you need, maybe do some edge AI, but it's going to take a long time to charge. So you may need to think about, do I need to boot? What level of boot do I need to do? If I'm doing security, I need secure boot coming soon. what levels of sampling of ADC do I need to do, what EPROMs I need to talk, and then do a fair final radio transmit. Too long or too short, then you're impacting the user functionality. So it's kind of coming down to how is the user going to do it, how much reporting I need to do, and what available resource I've got to me to pick the right kind of solution for you.
All good questions. I think all well encapsulate the fun challenge of engineering and working in technology. Before we finish, Stephen, is there anything you want to mention to those that are listening?
I guess just one final thing, more than anything, is to make sure engineers and designers alike, or people listening to the podcast, really think about what does the future look like in terms of energy harvesting. Where is it kind of going, and probably even delve into some of the bits that I've spoken about. Alternatively, just reach out to me on LinkedIn or however, and I'm happy to have a general chit chat, because I do like engineering and I like to help people. So as a tech enthusiast myself, I'd love to hear what people have got to say.
Well, thank you so much, Stephen, for being here. I really enjoyed our conversation.
And me as well. And thank you very much for inviting me on. It's been great.
IoT Unplugged.